All right, I'm going to talk you through this calculus problem right here. So this one gives us an equation for the speed of a bullet. It tells us the equation for the velocity of this bullet right there. It's negative 5 times 10 to the 7th t squared plus 2.65 times 10 to the 5th t. Okay? So at time t equals 0, the velocity is 0. If we plug in zeros for both of those, we'll get 0. And the speed is going to be increasing up to a point, okay? And at that point is when it leaves the barrel, and it should just, from then on, it would just, I imagine, continue at a constant velocity because there's nothing else pushing it. So here is our setup so far. The acceleration of the bullet is, just as it leaves the barrel, is 0. Determine the acceleration and the position of the bullet as a function of time. So this is our velocity equation. We're trying to find the acceleration and position equations in this case. So the acceleration equation, acceleration is the change in velocity. So it's going to be the slope of the velocity. So for this, what we're going to do is use the power rule to come up with an equation for the acceleration. So the acceleration is going to be equal to, and since our first term is negative 5 times 10 to the 7th t squared, what we're going to do is take this exponent, the 2, and bring it down to the front. Multiply it by the coefficient in the front. So it's going to be 2 times negative 5, which is going to be negative 10 times 10 to the 7th. And then it's t to the 1. So this is also just going to, in this particular case, it's just going to be equal to negative 10 to the 8th times t. And then for the second part, it's going to be 2.65 times 10 to the 5th t to the 1 power. And so what we're going to do is multiply the front by 1, which is just the same as what it was before. And then t is going to be raised to the 0th power instead. So this is just going to be plus 2.65 times 10 to the 5th. So this is our equation at this point for the acceleration. And if I go ahead and reveal, we've got there negative 1.000, and it does want you to use scientific notation here, so what you would enter into the box is just like this, negative 1.00, because it wants you to round to exactly 3 significant figures, plus 8, or e, so lowercase letter e, and then you don't need this plus 0.8, just the number 8 would be fine. So what I would enter into the box would be negative 1.00, little e, 8, then yeah, times t plus 2.65 little e 5. And that would be my answer for this problem. Next up for the position. Now position is the other way around. Velocity is the slope of the position. So we need to do an anti-derivative in this case, or we integrate the function. So rather than doing the regular power rule, we're going to do the reverse power rule in this case. So at the end, this t to the 1 should actually be a t to the 2, and this t to the 2 should be a t to the 3. So what we're going to do is make this one a 3, make this one a 2, and then divide this term by 2, divide this whole term by 3. So I'm going to write that out for you. The position function is going to be equal to negative 5.00 times 10 to the 7th divided by 3 times t squared plus 2.65 times 10 to the 5th over 2 t squared. Oh, I'm sorry, this one is actually t. So that's our equation right there. So you'd have to do 5 over 3, which would be what, like 1.67 times 10 to the 7th t cubed, plus, and then 2.65, divide that by 2, and you get what, 1.33? And so let's see, 1.32. So here's our equation in that case for this one. So it'd be 1.67 E7 t caret 3 plus, oh, and that's negative, plus 1.33 E, or sorry, E5, not E10, E5, then t caret 2, as it goes into that equation box. That would be the way that you can answer these first parts for part A. this would give you a function for the position and a function for the acceleration. Next up for part B, it says determine the length of time the bullet is accelerated. So we're trying to figure out how long is it accelerating for. So if we knew the length of the barrel, we could figure out when it got to that length. And actually that's one of the questions down here, but we don't know that. If we knew the speed at which it leaves the barrel, we could plug that into our velocity equation which they gave us, and that would tell us it. But we don't know the length or the speed at the end, but what we do know is the acceleration at the end. It tells us the acceleration is 0. So we can go ahead and say, well then, our acceleration function as a function of time is going to be equal to 0. So what we can just do is this whole thing, negative 10 to the 8th t plus, oh, and sorry, so this would be when t is equal to, yeah, we're solving for t, plus 2.65 times 10 to the 5th. That equals 0. So then you just solve for t, and you should get that t is equal to 2.65 times 10 to the 5th over 10 to the 8th in this case. So that would be 2.65 times 10 to the 13th, I believe. So that's what we got. Oh, it's because we're dividing, it's not dividing by -8, it's the whole thing is negative, sorry. So let's actually go through the steps of the algebra so we don't make silly mental math mistakes like I was just doing. And so if we actually solve for this, we get, first we'll bring this over to the other side. So subtract it from both sides and we get this equation right here. And then divide both sides by 10 to the 8th. And then we get we get 10 to the -3 as our new value in that case. So it's going to be 2.65 times 10 to the -3. Or e -3. Or you can just put it in as decimal like they do there. Next part. Find the speed at which the bullet leaves the barrel. So what we're going to do is take this number right there and plug it into our velocity equation. Let's go ahead and do that. It's going to be 2.65 e -3. That's going to be our time. And so we're going to use that and just plug it straight into that equation up there. So square that, then multiply by -5 e7. And then we need to add 2.65 times 10 to the 5th power times 2.65 times 10 to the -3rd power. And we get 351.125 meters per second, which is right there what it says for this answer. And the last one is, what is the length of the barrel? So for this, again, we just take the same time, and instead of plugging it into the velocity equation, we're going to plug it into the position equation. And I think I'm going to leave that one for you, but what I would wind up doing is, well, I'll just do it real quick here and fast forward. There we go. And I get that it's 61 centimeters long, which is what we get right there. So if you want to see the whole calculation, it's right up here. And you can see it as I scroll through. So just plugging into this equation, plugging in 2.65 times 10 to the -3, or over here I typed it in the other way, 0.00265 squared and cubed. And that should be about it. Good luck with this one. If you still have questions about this one, please let me know, and we can take a look at it in class or on individually.